In this video, we're going to explore the area under curves. To do that, we're going to review a little bit on dissection. So we have this trapezoid here. We're going to try to find the area of this. And to do that, we're going to break this up into known shapes. So we're going to break this up into a rectangle and a right triangle, or two right triangles actually. So we're going to find first the area of the rectangle, 1, 2, 3, 4, 5, 6 by 3. The area is 18. On the right side, we have a triangle of base 2 and height of 3. So the area of that would be 3. And on the other side, we have a triangle of base 3 and height 3, so the area is 4.5. So when we add all these up, 18 plus 3 plus 4.5, we get 25.5 for our area. Now the point of this is that we're going to do the same basic thing today, or in this video, when we're looking at the area under curves. But the difference is our shapes are not necessarily going to go have a vertical or horizontal scale of 1, so that's going to be something we have to be careful of. And they're always going to fall on the x-axis or the t-axis. So as an example, like number 2 here, find an area of the polygon formed by the t-axis and the graph of v from t equals 0 to t equals 24. So telling you specifically, only look in this area. So the first thing I notice is that it looks like we have kind of another trapezoid. I can drop in my vertical lines right here and here. And what I've done is I've broken that down into a rectangle and two right triangles. So the trick is, notice that the scale on the bottom is by 4s, it's not by 1s, and the vertical scale is by 5s. So if we're looking at the distance here from 4 to 6, that's 12, and our height from 0 up to 20 is 20. So I know that that area is going to be 240, because that's just 12 times 20. When I've got my base here of 8 and my height of 20, I can find the area of that by multiplying those two together. My area is 80. And I do the same thing here, base of 4, height of 20. The area is 40. So when I add these up, I have 240 plus 40 is 280 plus 80 gives me a total area of 360. Now contrast that with number 3, where notice we have this like negative area, the stuff underneath the x-axis. We're not going to concern ourselves with that. In fact, the stuff we're going to look at will restrict us just from 0 to 9. We're not going to find any of that stuff in there. So again, it looks like another trapezoid. I'm going to drop these guys down. And our scale here is by 2s, and then our vertical scale looks like by 10s. So from 2 to 7, that's a 5, and that's a 20. So that area is 100. Here we have from 7 to 9, that's 2. So the area of that is 20. Here we have a base of 2 and a height of 20. So again, 20. When I add those up, I get 140. Let's look at a more complicated shape. Yeah, sure, let's look at this one. So we're going to find the area of this from 5 to 12. So again, all this stuff in here we're not really concerned with. It's just from here to here. So what I'm going to try and do is break it up into as few shapes as I can, but I want to make sure that I've set up rectangles and right triangles. So I'm going to kind of start at the ends and go where I have a right triangle. So it looks like right here would form a nice right triangle, as would this. And so I think if we draw in that right there and this right here, that's going to give us 5 different shapes that we're going to find the area of. Not too bad. Notice that our scale down here is by 1s, and our vertical scale is up by 0.1s. That's a key distinction here. So we've got 1, 2, 3, 4, 5, and a height of 0.2. So the area of that is just 1. Here we have a base of 1 and a height of 0.2. So that area is 0.1. Here we have a base of 1 and a height of 0.3, so it's 0.015 for that area, 1/2 base times height. Here we have a 1 and a 0.1, So that area is 0.05, 0.1 divided by 2. And this little rectangle right here has a base of 1 and a height of 0.1, so the area is 0.1. So when we add all these up, let's see, we got a 1, and this would give us a 0.2, 0.3, 0.4. The area would be 1.4. If you found 14, you're on the right track. You found the area of all those shapes, but that vertical scale being 0.1 kind of throws us off a little bit. And I think this is the one where we're going to stop at. I just want to show how to break this apart because I think this one gets a little bit complicated. Again, if you're looking for right triangles and rectangles, it makes it a little bit easier. It looks like it kind of tapers off at the end, so I'm going to set this one up here. And I'm noticing that we have another right triangle that just kind of pops out here. And another one here. And then so we have, depending on how you cut it, if you cut it this way, you're going to have a rectangle here and here, and then 3 right triangles. If you cut it vertically, you'd have a rectangle here and here. In the end, it's going to give you the same idea. Just want to show you how to break that one up, and again, there's no wrong way to do it as long as you're breaking them up into rectangles and right triangles, known shapes that you can find the area of. And that's really the difference between this section and the previous one. There's just a little bit more that we have to break up.